This poster will address the use of a portfolio of visual tools as a substitute for physical equipment when teaching principles of digital logic as part of a computer science course or curriculum. With the shift to virtual classrooms and hybrid instruction for remote students, such tools can assist students with mastering the basic concepts related to digital logic. After resuming in-person instruction, these tools can be used in conjunction with the physical tools for enrichment purposes. The onset of the COVID-19 pandemic required a rapid shift to online instruction for nearly all classes in the early spring of 2020. This shift had major implications for material that relied on physical tools such as digital logic modules and computer science courses. Prior to the pandemic, it was possible to use physical tools such as snap circuits, the Turing Tumble, and breadboards to allow students to interact with the material in a tactile manner. This poster presentation will examine a set of virtual tools that will allow students to explore the applied nature of digital logic and assembly language in an interactive and virtual manner. The primary target audience is secondary school teachers who are teaching computer science courses, although university faculty teaching digital logic courses to lower division students may also be interested in this material. The overall development of a portfolio-based approach to virtual tools as substitutes for physical tools should be applicable to a wider audience. This poster presentation will hopefully be of interest to educators hoping to incorporate a playful approach to digital logic within their classroom and should generate discussion as to the best practices for incorporating virtual tools into the curriculum for digital logic. We can begin by looking at the physical tool that also has a virtual implementation. This is the Turing Tumble. According to its creators, the Turing Tumble is a revolutionary new game where players, ages 8 to adult, build mechanical computers powered by marbles to solve logic puzzles. The Turing Tumble focuses on the components that make up the digital hardware in the computer. The Turing Tumble has marbles to simulate bits, ramps that can direct balls in one direction or another, bits to store information, interceptors to stop the machine from releasing more balls, and gears that store logic and have different outcomes depending on their start position. The Turing Tumble provides a good simulation and tactile method of teaching. It also has an accompanying graphic novel to motivate students in completing the puzzles. The good news in moving to the virtual environment is that there is a virtual emulation of this tool from the publishers that teaches all the core concepts. However, the virtual version lacks the, quote, satisfying cascade of marbles that our playtester Dallas most enjoyed. Prior to the pandemic, snap circuits were a popular tool for teaching digital logic to students 8 years and up. Like the Turing Tumble, there was a tactile approach to this educational toy, which allowed students to learn digital logic design and gate components. Unfortunately, the virtual nature of the classroom during the past year and the high-flex classes of the future, along with decreased university budgets, make this approach difficult to implement. Fortunately, there's Circuitverse. This is a virtual and free alternative tool, which allows students to explore a variety of topics related to digital logic, including simple gates, combinational circuits, sequential circuits, plot timing diagrams, and standard integrated circuits, amongst other topics. The site also comes with a free open educational resource textbook that can appeal to secondary students or lower division undergraduate students. A more complicated virtual and free tool is EDA Playground, which allows students with more advanced knowledge to code circuits in either Verilog or VHDL. While the tool is more advanced than one would like for an introductory course, the number of simulators and the waveform results are quite beneficial to students learning digital logic for the first time. Finally, assembly language is often associated with digital logic and hardware. Human Resource Machine is a mobile game designed to give players experience in assembly language programming. The game is centered around an office employee whose job is to take what is in the inbox, apply a set of instructions, and then put the solution in the output. The levels start off very straightforward to introduce basic commands and architecture. However, later problems cover topics such as sorting and prime numbers. Thank you so much for attending my poster presentation. If you have any questions, please feel free to contact me at hedwards@hawaii.edu. Thanks again.